Right, I'm going to think about sets of points. So I could think of a set of points like a circle, or a straight line, or a squiggly thing, or a parabola, or, you know, something ridiculous. I'm thinking about sets of points like that. And there are two ways that you can tell someone about your set of points and about which points are in the set and which points aren't. So one way is that you can give a list or some description of how to find every point in the set one at a time. And another way is to have a rule that you can use to tell if a point you're thinking of is in the set or not. And these are quite different ways of thinking about a set. So in this one, if you told me a point, I could use the rule to decide whether it was part of the set or not. And maybe if it satisfied the rule, it wasn't in the set, and if it did satisfy the rule, it is in the set. And so you could give me points and I could tell you whether they're in the set or not. But I couldn't necessarily from the outset just tell you what the points in the set were. On the other hand, this one, I've got a list and some sort of thing that will tell me what the points of the set are. If you ask me for points in the set, I can list them for as long as you want. But it might not be very difficult, it might not be very easy for me to tell you exactly whether a point is in the set or not if you ask me. Because the only way for me to tell will be to try and make one that matches. So these are two different ways of talking about the points in a set. And this one is when you have some sort of relation between the coordinates of the point that tells you whether it's in the set. And that's usually in the form of an equation. So if the coordinates are related in the right way, then they're in the set. And if they're not related in that way, then they're not in the set. On the other hand, if you want to tell every point in the set, that is what's normally done with a parametric description. Where you have some sort of variable that tells you how to calculate points that are in the set. And that's the main difference. So as an example, if I had a straight line like this, I could give you a rule for telling whether a point is on this line or not. X, Y on the line when x plus y is equal to 8. And so we could ask, is 1, 6 on the line? Well, x plus y would be 1 plus 6, which is 7, which is not 8, so no. And is 2, 7 on the line? 2 plus 7 is, well, x plus y is 2 plus 7, which is 9, which is not 8, so no. Is 3, 5 on the line? X plus y is 3 plus 5, which is 8, so yes, that one is on the line. Okay, so I could do that forever and just slowly cross out ones that aren't on the line and colour in ones that are on the line, and then eventually I'd find where the line is. On the other hand, I could just tell you what all the points on the line are. So I could say something like, the points on the line are of the form let me just think about this. 8 minus t for any number t. And so if you said, oh, tell me some points on the line, I could say, okay, so when t is 1, we get 7, 1, and when t is 0, we get 8, 0, and when t is 3, we get 5, 3, and so on. I can list points on the line till the cows come home. And there are two different descriptions of this line. On the other hand, when I think about this line, there is one other way to describe it. I could tell you, based on what the x-coordinate is, what the matching y-coordinate has to be. And in a way that's very similar to this. And it's in another way similar to this. And so I can think of this as a function which takes an x and tells me what the matching y has to be. And that equation that relates it can do both of these tricks simultaneously. I can go, well, if I know what the correct x is, then the y has to be 8 minus x. And what that means is that the points on the line are, so this is simultaneously a rule to check if the point is on the line, and it also tells me that all the points on the line are x and 8 minus x. And so it simultaneously tells me both things, which is why functions are nice, because they allow me to represent my points simultaneously, parametrically, and parametrically and implicit rule-wise. So that's my take on the three different kinds of descriptions of a set. Some things can't be represented in one way or the other. Almost all things that we care about have both an implicit equation version and a parametric version. Only functions also have a function version, which is both.